everybody, I am Ayush Prasad in the Funtastic Academy. In the last video about light, we learned about the different scientists who contributed greatly to our knowledge about light. And I asked a quiz question, as I always do. The quiz question is as follows. Which scientist performed the double slit experiment? And did the double slit experiment support the wave theory of light or the particle theory of light? Answer: Thomas Young performed the double slit experiment, and that experiment supported the wave theory of light. Okay, with the quiz question covered, we can now go on to the topic of this video. What exactly makes this can of paint they have with me here red? What makes it red? And for that matter, what makes this can green? And what makes this can blue? What makes all these cans? And for that matter, anything in the universe, the color they are? Well, the topic of how our eyes and brains perceive color is a topic for a supplementary video. But in this video, I want to focus more about how the light is absorbed and reflected by the objects, and along the way also teach you a bit about properties of light. But to get started, we need to learn about the frequency of light, the wavelength of light, and the amplitude of light. Okay, so light comes in waves, like this. Now, all waves have a few properties. First property is the amplitude. The amplitude is basically how tall a wave is. So if you draw a line cutting the wave into two parts, the height of that wave from that line is the amplitude. Second of all, the second property of a wave is wavelength. Now all waves have toppy points called crests and bottomy points called troughs. And wavelength is just the distance from a crest to a crest or a trough to a trough. Finally, there's frequency. So imagine that the wave starts at 0 seconds here, and this is 1 second here. So frequency is basically how many waves are between 0 seconds and 1 second. So there's 1 wave, 2 waves, 3 waves. So frequency, if this is 3. Now, frequency is measured in hertz. So the frequency of this wave is 3 hertz. Now, the most important of these 3 properties is the wavelength. Why? Because it just so happens that red light has a bigger wavelength than yellow light, and yellow light has a bigger wavelength than purple light. That's the difference between red light, yellow light, and purple light. That's really the difference between those colors. Okay, but how are objects colored? How do objects get colored? To find out, we're gonna shine some light on some paint cans. So we just learned that red light has a big wavelength and purple light has a tiny wavelength. What does this all have to do with color? We'll understand this by shining light on each of these paint cans, starting with the red paint can. So when I shine light on the red paint can, it appears red. No surprise here. But why? If you watched the last video on the prism, you will have known that Newton proved that red light is made out of many different colors, zillions of colors in fact. Some of these zillions of colors are hitting the paint can. But But what happens when they hit the paint can? Well, you can imagine the paint can as a noisy toddler, which will only drink some of its milk, but not all of it. The wet paint can is just like that. It drinks most of the light. Scientists say it absorbs most of the light, but it doesn't drink the red light. So all the red light just bounces off of the wet paint can and into the camera, and that's why you see it being red. Next, let's try the green paint can. Using the toddler analogy, this time the green paint can is drinking all of the light, but it doesn't drink the green light. So the green light just bounces off of the paint can into the camera, and you see green light. The same exact thing is happening for the blue light. It drinks all of the light, but doesn't drink blue light. So the blue light just bounces into the camera, and you see blue light. So these paint cans absorb all the colors except their true color. The red absorbs every single color except red. Green absorbs every single color except green. And blue absorbs every single color except blue. So in some ways, the color that objects are is the exact opposite of the color they are. Okay, so let's end this episode with a simple quiz question. Which color of light has the shortest wavelength? Give me your answer, and you'll see me again in the next episode of Light. Bye bye!